The star of Betelgeuse, a brilliant red tremendous monster found in the heavenly gathering of Orion, has captured stargazers and cosmologists alike for a long time because of its sheer size and brightness. Assuming Betelgeuse were put where our Sun is, it would expand to the circle of Jupiter. Despite its immense size, Betelgeuse is approximately 642 light-years away from Earth. Its enormous size makes it potentially one of the most awe-inspiring stars apparent to the untrained eye. Actually, Betelgeuse has shown odd behavior, such as surprising clouding and enlightening cycles, which various investigators believe signal that the star is nearing the completion of its life. Recently, the well-known physicist Brian Cox provided a fundamental statement that Betelgeuse is on the edge of a stunning effect, expected to occur within the next 14 days. This event, known as a supernova explosion, will mark the completion of Betelgeuse's existence. However, it will provide an unexpected chance for researchers to concentrate on one of the most bewildering areas of strength and characteristics in the universe. As a red supergiant, Betelgeuse is named one of the largest and most massive varieties of stars. It has been on the cosmic radar for quite a long time, but its recent fluctuations in brightness have sparked theories that it is getting ready for a vast explosion. When a star like Betelgeuse reaches its final stage, its core collapses under its own gravity, prompting a tremendous blast that ejects a massive amount of energy, radiation, and material into space. Betelgeuse's forthcoming blast is supposed to be a Type II supernova. This specific type of celestial event occurs when a massive star's core breaks apart. This collapse triggers the release of neutrinos and radiation, creating a shock wave that obliterates the star. The blast will be so bright that it could be visible from Earth without telescopes, possibly even outshining the moon in the night sky for several weeks or months. While such an event would ordinarily be catastrophic if it happened near Earth, Betelgeuse's distance of around 642 light-years means that, although the blast will be visible and dramatic, it will not pose any danger to life on our planet. Nonetheless, the event promises to reshape our understanding of supernovas and other cosmic phenomena. A supernova explosion is one of the most powerful events in the universe, releasing more energy in a fraction of a second than the Sun will in its entire lifetime. Betelgeuse's blast will not only be an incredible cosmic display but also a crucial time for science. Researchers are eager to observe this event from its earliest moments using an array of ground-based and space telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to capture as much information as possible. When Betelgeuse explodes, it will release a wide range of radiation, from gamma rays to visible light. One of the key components of this cosmic explosion will be the flood of neutrinos, elusive subatomic particles that rarely interact with matter. Neutrinos from a supernova can actually reach Earth before the light from the blast due to their ability to pass through nearly anything without being impacted. Observatories like Japan's Superkamiokande and the IceCube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, providing an early advantage in tracking Betelgeuse's explosion. The blast will also provide significant insights into the creation of heavy elements. When stars explode, they produce and scatter elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse supernova will give researchers a better understanding of how these elements form, which is critical for understanding the development of planets and the chemistry of the universe. While Betelgeuse's explosion is not likely to have a negative impact on Earth, it will interact with our planet's atmosphere and magnetic field in fascinating ways, specifically through the blast's energy surge. The emission of cosmic rays and charged particles may result in more intense auroras, extending the regions where the northern and southern lights are visible. Although these powerful rays could influence satellite communications and some technologies on Earth, the disruptions are expected to be minor and short-lived. Perhaps one of the most intriguing aspects of Betelgeuse's explosion is that it will be visible to everyone on Earth, not just professional astronomers with advanced equipment. For a few months, or possibly even longer, Betelgeuse is expected to be the brightest object in the sky, potentially even visible during the daytime. This event will not only excite professional scientists but also amateur astronomers and the general public, sparking renewed interest in space science and the universe. Scientists have speculated for a long time about Betelgeuse, but Brian Cox's recent statement adds urgency to the matter. Observatories worldwide are preparing to monitor each phase of the cosmic explosion, and the data gathered will be crucial, potentially changing our understanding of stellar evolution, cosmic explosions, and the distribution of heavy matter in the universe. The explosion of Betelgeuse will allow researchers to refine their models of cosmic distances. Being relatively close to Earth, it offers a unique opportunity to measure how energy from such an explosion travels through space. By observing the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust between stars, cosmologists will gain a clearer understanding of the size of the universe. This event will also provide a rare chance to investigate dark matter and how it might influence the structure of the universe. Dark matter, the mysterious substance that makes up around 85% of the universe's mass, does not generate or absorb light, making it difficult to detect. However, observing how matter and light interact with one another after Betelgeuse explosion could provide indirect hints about dark matter's role in the large-scale structure of the universe. The cosmic explosion of Betelgeuse will bring us closer to understanding the life cycles of stars, especially how massive stars contribute to the creation of elements essential for life. Supernovas are critical events responsible for spreading heavy elements throughout the universe, which eventually form new stars, planets, and even living things. By studying Betelgeuse, scientists will gain valuable insight into the process of element formation and distribution. The social significance of Betelgeuse's impact is also important. For centuries, humans have looked to the stars for guidance, inspiration, and meaning. The disappearance of one of the most prominent stars in the Orion constellation will prompt philosophical reflection on the transient nature of the universe. In some cultures, such cosmic events have been interpreted as signs of great change. Betelgeuse's explosion may inspire a mixture of awe, fear, and wonder, as people from all walks of life witness the death of a star. This monumental event is likely to reignite interest in space exploration and stargazing, bringing more people into the pursuit of knowledge about the universe. Amateur astronomers are already preparing for the event, as modern technology allows nearly anyone with a camera or telescope to observe and record the cosmic explosion. The impact of Betelgeuse's explosion will extend far beyond scientific discoveries. It will likely inspire new discussions in philosophy, art, and even literature, as humanity grapples with witnessing the death of a celestial giant in real time. For centuries, supernovae have been recorded by ancient civilizations, often seen as omens or celestial messages. The famous SN 1054 supernova, which gave birth to the Crab Nebula, was recorded by Chinese, Japanese, and Arab astronomers over 1,000 years ago. Similarly, Betelgeuse's explosion will leave a lasting mark on human culture, possibly inspiring new myths, artworks, and even technological advancements. Observing Betelgeuse's supernova. Astronomers worldwide are preparing for an unprecedented opportunity to study this supernova across the entire electromagnetic spectrum. From radio waves to gamma rays, every available telescope will be trained on Betelgeuse when the explosion occurs. The James Webb Space Telescope, JWST, will provide detailed infrared observations, helping scientists analyze the elements being forged and ejected during the explosion. Meanwhile, radio telescopes like the Very Large Array, VLA, will track the interaction of the supernova's shockwave with interstellar gas, providing insights into how these powerful explosions influence the formation of new stars and planetary systems. The aftermath, a new cosmic landmark. Once the explosion subsides, Betelgeuse will leave behind either a neutron star or, if it is massive enough, a black hole. If a neutron star forms, astronomers will study its pulsations and magnetic field to gain deeper insights into the physics of these ultra-dense remnants. If a black hole forms, it could provide a rare opportunity to observe the birth of such an enigmatic object. Scientists will analyze how matter interacts with the newly formed event horizon, offering potential breakthroughs in our understanding of gravity and spacetime. A rare moment in human history. A supernova visible to the naked eye is a once-in-a-lifetime event, and Betelgeuse's explosion will unite astronomers, scientists, and the general public in a collective experience of cosmic wonder. It will remind us of our small yet significant place in the universe and the interconnectedness of all matter. From ancient stargazers to modern astrophysicists, humanity has always looked to the skies for answers. The death of Betelgeuse will mark both an end and a beginning, a reminder that from destruction comes creation, and that the universe is always in motion, shaping the future in ways we are only beginning to understand. As we await this spectacular event, one thing is certain: when Betelgeuse finally erupts into a brilliant supernova, the universe will be watching, along with every curious mind on Earth. Matter and dark energy. These two forces are believed to account for most of the universe's mass and energy, but they remain poorly understood. Some theorize that supernovas, like the one predicted from Betelgeuse, could hold the key to unlocking some of these mysteries. The amount of energy released by supernovae is enormous, and some researchers believe these powerful forces might interact with dark matter in ways we can observe and study. One interesting hypothesis is that dark matter exists as faintly interacting massive particles, known as WIMPs, weakly interacting massive particles. If WIMPs exist, their energy interaction, produced by Betelgeuse's cosmic explosion, could provide clues about their nature. Such a discovery would be groundbreaking, providing the first direct evidence of dark matter, a mysterious phenomenon that has puzzled scientists for decades. There is also potential for Betelgeuse's blast to offer insight into the nature of dark energy. Dark energy is the mysterious force driving the accelerated expansion of the universe. Understanding its contribution to cosmic evolution is one of the greatest challenges in modern physics. Betelgeuse's explosion could provide indirect evidence of dark energy's impact on stellar death, as supernovas are believed to be influenced by the universe's expansion. Observing how Betelgeuse's cosmic explosion propagates through space could offer vital information to help scientists understand how dark energy affects massive events and shapes the universe's structure on a grand scale. As Betelgeuse's cosmic explosion draws nearer, cosmologists are preparing for one of the most anticipated cosmic events of the century. The blast will provide a unique opportunity to observe the final phases of an enormous star, offering information that could impact our current understanding of stellar life cycles. While scientists expect a dramatic display, they are also refining techniques to study the aftermath of such an explosion. One area of focus is the creation of a neutron star, or possibly a black hole, in the remnants of Betelgeuse. A neutron star is the dense core left behind after a massive star like Betelgeuse undergoes a supernova explosion. These compact objects, which can have a mass greater than the Sun packed into a volume no larger than a city, are a key area of cosmological research. If Betelgeuse forms a neutron star, it will provide a unique opportunity to study the behavior of matter under extreme conditions. Neutron stars are also known to produce extremely strong magnetic fields and are sometimes observed as pulsars, emitting regular bursts of light. The formation of such a celestial remnant could offer crucial insights into the fundamental physics of extreme gravity and the behavior of matter at incredibly high densities. If Betelgeuse collapses into a black hole instead, it will be another major breakthrough for scientists studying the formation of these enigmatic objects. Black holes, regions of space where gravity is so strong that not even light can escape, have long been a subject of fascination and theoretical research. Observing the formation of a black hole from a relatively nearby star like Betelgeuse will help scientists refine their models of black hole formation and better comprehend their role in the universe. Additionally, it could provide new ways to observe the event horizon, the boundary beyond which nothing, not even light, can escape, offering further insights into the nature of black holes. Another major consideration is how Betelgeuse's explosion will contribute to our understanding of cosmic rays. These high-energy particles, which are produced in events like supernovas, can travel vast distances across the universe. While some cosmic rays are detected by Earth observatories, others have been difficult to study due to their erratic nature. When Betelgeuse explodes, its cosmic explosion will produce a huge amount of high-energy particles, giving researchers a chance to study cosmic rays in real time. This could enhance our understanding of how cosmic rays interact with the interstellar medium and what they might mean for space travel and technological systems on Earth. As the anticipated explosion of Betelgeuse draws closer, the scientific community is preparing for an event that will provide an unparalleled opportunity to study a star's death and its aftermath in real time. While supernovae are not rare in the universe, the proximity of Betelgeuse to Earth offers a unique chance to observe this cosmic event in unprecedented detail. The data gathered could significantly improve our comprehension of stellar life cycles, the process of star formation, and how supernova explosions contribute to the broader cosmic ecosystem. One of the exciting possibilities lies in the study of the interstellar medium. The explosion of Betelgeuse will expel vast amounts of gas and dust into space, which will interact with the surrounding materials in the Orion constellation. Researchers will closely monitor how these elements spread across the galaxy and interact with existing star systems. These materials, which include lighter elements like hydrogen and heavier ones like iron, will be crucial in forming new stars and planetary systems in the future. The ejected material will serve as a cosmic seed, contributing to the ongoing cycle of stellar birth and death. The explosion will also have important implications for our understanding of gravity and spacetime. As the relics of Betelgeuse either form a neutron star or collapse into a black hole, researchers believe they will observe how these dense objects warp spacetime in real time. Neutron stars, with their immense gravitational fields, are known to bend light and time. If a black hole is formed, it will provide an opportunity to investigate the warping of spacetime near its event horizon, offering further insights into Einstein's theory of general relativity. This event will also be a catalyst for new technological advancements. The vast amounts of data gathered from the explosion will be analyzed using cutting-edge methods of computation and artificial intelligence. This will not only improve our understanding of the universe but also push the boundaries of data science, allowing astronomers and physicists to process and interpret enormous datasets in ways never before possible. The implications of Betelgeuse's explosion extend beyond just scientific curiosity. This event will likely have a profound impact on multiple fields of astrophysics, including stellar evolution, nucleosynthesis, and the study of gravitational waves. One of the most exciting prospects is the potential detection of gravitational waves, ripples in spacetime first predicted by Einstein's general theory of relativity. If Betelgeuse undergoes a core-collapse supernova, the violent implosion could generate gravitational waves detectable by advanced observatories such as LIGO and Virgo. The ability to directly observe these waves from a nearby stellar explosion would provide an unprecedented opportunity to study how massive stars collapse and how energy is transported through spacetime. Additionally, Betelgeuse's explosion could shed light on the origins of heavy elements in the universe. Supernovae are responsible for forging elements heavier than iron, such as gold, platinum, and uranium, through a process known as rapid neutron capture, or the R process. By studying the remnants of Betelgeuse's supernova, scientists could gain crucial insights into how these elements are synthesized and distributed throughout the cosmos. Beyond its scientific impact, Betelgeuse's explosion will also have a profound effect on public engagement with astronomy. As one of the brightest and most well-known stars in the night sky, Betelgeuse's transformation into a supernova will be visible to the naked eye, even during the daytime. This event will captivate people around the world, sparking a renewed interest in space exploration and astrophysics. Telescopes, both professional and amateur, will be trained on the event, and the wealth of data gathered will fuel new discoveries for decades to come. The explosion will also serve as a real-time test for modern astronomical instruments. Space-based observatories like the James Webb Space Telescope, JWST, Hubble, and the upcoming Nancy Grace Roman Space Telescope will capture detailed images and spectra of the explosion, while ground-based telescopes such as those in the Very Large Telescope, VLT, array will monitor the event across multiple wavelengths. This multi-messenger approach, combining optical, infrared, radio, and gravitational wave observations, will provide the most comprehensive study of a supernova to date. Looking ahead, scientists are also considering the long-term consequences of Betelgeuse's explosion. As its ejected material expands into space, it will eventually enrich the interstellar medium, contributing to the next generation of stars and planets. Over time, these cosmic remnants may even play a role in the formation of new solar systems, possibly seeding planetary environments with the building blocks necessary for life. While the exact timing of Betelgeuse's supernova remains uncertain, astronomers are on high alert, continuously monitoring the star for signs of imminent collapse. Whether the explosion happens in a few years or a few centuries, it is destined to be one of the most significant astronomical events in human history, one that will deepen our understanding of the cosmos and inspire future generations of scientists and explorers.